Hello everyone, welcome back to our channel. Your metric trial exam is finished. Now you are preparing for the final exam. Today I am discussing a simple unit from paper 2, physical science, that is acids and bases. Some of the basic concepts of acids and bases you learned in grade 11. And some extended topic we are studying this year. So I am starting with some of the basic concepts of acids and bases. Acids taste sour. Acids turns blue litmus paper red. Increases the concentration of H plus in a solution. Its pH value is less than 7. Decreases the concentration of OH minus. So the first point is it tastes sour, and in some of the questions you can see their identification. Acids taste sour. It turns blue litmus paper red. So in a question paper, if you are seeing blue litmus paper turning red, that means acids we used. It increases the concentration of H plus ion or H3O plus ion. H plus ion or H plus ion. Its pH value is less than 7. Its pH value is less than 7. So all acids and their pH value is less than 7. It decreases the concentration of OH minus ion. So if you are having an acid increases the concentration of H plus or H3 plus. It decreases the concentration of OH minus. Bases taste bitter and has a soapy feel. So it tastes bitter and has a soapy feel. Turns a red litmus paper to blue. So if in a question paper, if you see a red litmus paper turning blue, that is an indication of base, that we are using bases. We are using a base there. Its pH value is greater than 7. All bases, they are having pH value greater than 7. It increases the concentration of OH minus. It increases the concentration of OH minus. It decreases the concentration of H plus or H3O plus. They are just opposite. Here it increases the concentration of H plus ion. Here it decreases the concentration of H plus. Here it decreases the concentration of OH minus ion. Here it increases the concentration of OH minus. So they are just opposite. So acid means it will increase the concentration of H plus or H3O plus. Base means it will increase the concentration of OH minus ion. So these are some basic concepts related to acids and bases. Then we can learn scientific models of acids and bases. Scientific models of acids and bases. Scientific models. First, we are learning Arrhenius theory. Arrhenius theory of acids and bases. Arrhenius theory. So according to Arrhenius theory, what is an acid? According to Arrhenius theory, what is an acid? So acid is a substance that can produce H plus ion or H3O plus ion in an aqueous solution. in a solution. Arrhenius theory. Arrhenius theory of acid. In some question papers, you can see define acid on the basis of Arrhenius theory. So acid is a substance which produces H plus ions or H3O plus ions in an aqueous solution. For example, HCl is an acid. HCl is an acid. Why HCl is an acid? Because HCl can produce H plus ion or H3O plus ion in an aqueous solution. In an aqueous solution, HCl can give H plus or H3O plus. So that's why HCl is an acid. So according to Arrhenius theory, how can you define an acid? An acid is a substance which can produce H plus ion or H3O plus ion in an aqueous solution. So that way you can understand. Then, according to Arrhenius theory, what is a base? What is a base? Base is a substance. Base is a substance which can produce OH minus ion in a solution. Base is a substance which can produce OH minus ion in an aqueous solution. For example, NaOH, it's a base. According to Arrhenius theory, how can you say NaOH is a base? Because NaOH can produce OH minus ion in the aqueous solution. So NaOH is a base or it's an alkali. It's an alkali or a base. According to Arrhenius theory, it can give OH minus ion in an aqueous solution. So according to Arrhenius theory, acid and base, they are very important. Acid is a substance which can produce H plus ion or H3O plus ion in an aqueous solution. Base means it's a substance which can produce OH minus ion in an aqueous solution. So these two definitions are important. According to Arrhenius theory, define acid and base. Next model is Lowry-Bronsted theory. Lowry-Bronsted theory. Lowry-Bronsted theory. So, according to Lowry-Bronsted theory, what is an acid? Acid is a substance which can donate a proton, or simply you can say acid is a proton donor. Acid is a proton donor. For example, HCl is an acid according to Lowry-Bronsted theory. How? HCl can give H plus. H plus is a proton. H plus is a proton. So H plus can give a proton. So H plus is a proton donor. H plus is a proton donor. So according to Arrhenius theory, acid is a proton donor. Then according to Arrhenius theory, what is base? Base is a substance which can accept proton. So base is a substance which can accept proton. Or you can say it is a proton acceptor. So base is a substance which can accept proton. So base is a substance, it's an acceptor of proton. Acid means a donor of proton. Base means acceptor of proton. So these two theories are very important. According to Arrhenius theory, acid is a substance which can give H plus ion or H3O plus ion in an aqueous solution. Base means it's a substance which can give OH minus ion in an aqueous solution. So these two definitions according to Arrhenius theory. Then another theory is there, Lowry-Bronsted theory. According to Lowry-Bronsted theory, acid is a substance or acid is a proton donor. Base is a proton acceptor. So you must differentiate these two definitions, Arrhenius theory and Lowry-Bronsted theory. Don't make mistakes when you write. If it asks Arrhenius theory, you must write Arrhenius theory only. Don't write Lowry-Bronsted theory. Or if the question asks Lowry-Bronsted theory, only write Lowry-Bronsted theory. Don't write Arrhenius theory. So these two definitions are very important for the exams. So these two theories are almost same, but they are explaining acid and base in different way. They are saying the same thing. They are saying same thing, but they are explaining in different way. So Arrhenius theory of acid and base, Lowry-Bronsted theory of acid and base, they are very important. Then we can study conjugate acid and conjugate base. Conjugate acid and conjugate base. So conjugate acid and conjugate base, they are forming from acid and base. In many of the questions, they are asking by giving a chemical equation. By giving an equation, find out conjugate acid, conjugate base, or write conjugate acid and conjugate base corresponding to a chemical reaction. So they are very simple. What do you mean by conjugate acid? So you know that acid plus base, it gives conjugate acid plus conjugate base. Acid plus base giving conjugate acid plus conjugate base. So this is a forward and reverse reaction. In the forward reaction, acid and base gives conjugate acid and conjugate base. In the reverse reaction, conjugate acid and conjugate base gives again acid and base. So from a reaction, how can you say which is conjugate acid and conjugate base? So conjugate acid can give conjugate base. Conjugate acid can give conjugate base. And base can give conjugate acid. Conjugate acid. So in the forward reaction, an acid can give conjugate base. In the reverse reaction, conjugate base can give acid. In the forward reaction, base can give conjugate acid. In the reverse reaction, conjugate acid can give base. So how can you get conjugate acid, or how can you form conjugate acid and base? They are very simple. When acid donates a proton, conjugate base will form. Conjugate base will form. When base accepts a proton, conjugate acid will form. Conjugate acid will form. When acid donates a proton, conjugate base will form. When base accepts a proton, conjugate acid will form. So you can simply identify these conjugate acid, conjugate base, acid base from a chemical reaction. So from a chemical reaction, you must know which is acid, which is base, and which is conjugate acid, which is conjugate base. So on the right side you can see conjugate acid and conjugate base. On the left side you can see acid and base. So from an acid and base, conjugate acid and conjugate base is forming. From a base you will get conjugate acid. From acid you will get conjugate base. Then we can discuss from an acid how a conjugate base is forming. Acid, conjugate base. For example, H2O. If you consider H2O as an acid, from H2O, remove a proton. Remove a proton. So that means H plus is removing. H plus is removing. You will get OH minus. You will get OH minus. Remove a proton from H2O. You will get conjugate base. Another example, HCl. Remove a proton. That means H plus. You will get Cl minus. So from H2O you are removing a proton, you will get OH minus. From HCl remove a proton, you will get Cl minus. Then HSO4 minus form the conjugate base of this acid. Remove H plus, then it becomes SO4 2 minus. SO4 2 minus. Another example, HPO4 2 minus. How can you produce conjugate base of this acid? So you will get like this, PO4 3 minus. PO4 3 minus. So you will get the conjugate base of this acid. So from here you are getting conjugate base from acid by removing a proton. By removing a proton. H2O, the corresponding conjugate base is OH minus by removing a proton. HCl, you will get Cl minus by removing a proton. HSO4 minus, you will get SO4 2 minus. HPO4 2 minus, PO4 3 minus. So in some question papers you can see form the conjugate base from a corresponding acid, or from a reaction find out the conjugate base. So this way you can form it, or you can identify it. So you can write even a chemical reaction, how you are getting a conjugate base from an acid. So this is the way how to get a conjugate base from an acid. So these are some examples. Next we can check base and conjugate acid. Base and conjugate acid. Example, H2O. H2O can act as acid and base. In the previous example it is acting as an acid. So here it is, we are taking as a base. So from H2O how will you get conjugate acid? How will you get it? Add a proton to it. So a proton means H plus. So when you add proton to H2O you will get H3O plus. So you are adding H plus to this. That means adding a proton. So H2O is a base, corresponding acid is H3O plus. Then NH3, it is a base. How will you get the corresponding conjugate acid? How will you get the corresponding conjugate acid? Add a proton. That means adding H plus. So you will get what? NH4 plus. NH4 plus. Then HSO4 minus. Add H plus to this. When you add H plus to this, you will get what? H2SO4, H2SO4. This minus sign will be removed. So you are adding H plus to this. You will get H2SO4. Then SO4 2 minus. How will you get? Add H plus. So HSO4 minus. These are the base and conjugate acid. So from a base, how can you form conjugate acid? From a base, how can you form conjugate acid? Add a proton. From an acid, how will you get conjugate base? Remove a proton. So from an acid, you will get conjugate by base by removing a proton. From a base, you will get conjugate acid by adding a proton. So these are the ways you can get conjugate acid and conjugate base. So there will be sure questions in metric related to conjugate acid and conjugate base. So conjugate acid, how can you get it? Conjugate base, how can you get it? So from a substance, how can you form conjugate acid? From a substance, how can you form conjugate base? From a reaction, how will you find out the conjugate acid and conjugate base? Or how can you write a reaction with acid base, conjugate acid and conjugate base? So these are the types of questions it can ask. So you must ready with the conjugate acid and conjugate base. Next I am explaining reactions. Generally, when an acid reacts with base, you will get salt and water. Salt plus water. So if you are having a reaction of acid and base, for example, HCl is an acid, NaOH is a base. When it reacts, you will get salt, NaCl plus H2O. So generally, when an acid and base reacts, it will always produce salt and water. For example, HCl plus NaOH gives NaCl plus H2O. So if you see anywhere in a question paper with an acid and base, so you should know the acid and base. If the reaction consists of only acid and base, it will produce always salt and water. HCl plus NaOH gives NaCl plus water. Then some other reactions of acids with metals. Reactions with metals. So acid plus metal hydroxide. Acid plus metal hydroxide. For example, HCl plus NaOH. HCl plus NaOH. So acid plus metal hydroxide. It always gives salt and water. NaCl plus water, H2O. So if you see a reaction of metal hydroxide means it's a base, and acid, it always gives salt and water. So if you see a reaction with acid and metal hydroxide, it always gives salt and water. So you must learn only this general equation. Acid plus metal hydroxide gives salt and water. Acid plus metal hydroxide gives salt and water. So that is the first. Acid plus metal hydroxide gives salt and water. So you must remember that. Second, acid plus metal oxide. Acid plus metal oxide. I can give an equation H2SO4 plus CuO. H2SO4 plus CuO. H2SO4 is an acid. Cu, it's a metal. CuO, it is a metal oxide. It also gives salt and water. It also gives salt and water. So here the salt is CuSO4 plus water. CuSO4 plus water. So an acid plus metal oxide, it always gives salt and water. An acid plus metal oxide, it always gives salt and water. Acid, for example, H2SO4. CuO, it is a metal oxide, copper oxide. It gives copper sulfate and water. So you must learn this general equation. So when you learn the general equation, if you have a question, check the question. Reactant side, one of the reactant is acid, another reactant is metal oxide. By seeing itself you can understand. Acid plus metal oxide, it always gives salt and water. So you can easily write the product side. You can easily write the product side. So that way you have to learn. You must learn the general equation. Then third, an acid and metal carbonate. An acid and metal carbonate. That is the third one. That is the third one, acid and metal carbonate. For example, NaHCO3. NaHCO3 plus HCl. This is a metal carbonate and this is an acid. So what is the general equation for that? General equation is salt plus water plus carbon dioxide. Salt plus water plus carbon dioxide. So here it will be NaCl, salt plus water plus carbon dioxide. So general equation you have to memorize like this. Acid plus metal carbonate, it gives salt and water plus carbon dioxide. So if the reaction is with the metal carbonate, if the acid is reacting with the metal carbonate, it is giving salt, water plus carbon dioxide. So this is a metal carbonate and this is an acid. So it will always give salt, that is NaCl, water plus carbon dioxide. So this is the third reaction. Then fourth one, acid plus metal hydrogen carbonate. Metal hydrogen carbonate. For example, HCl, 2HCl plus MgHCO3 twice. CO3 twice. It gives salt plus water and carbon dioxide. Salt plus water and carbon dioxide. So this is an acid and this is metal hydrogen carbonate. Metal hydrogen carbonate, it gives salt. Which is the salt here? MgCl2. Then water, 2H2O plus carbon dioxide. Plus carbon dioxide. So an acid plus metal hydrogen carbonate, it also gives salt, water plus carbon dioxide. So these are the basic equation. If you can learn one more equation, acid plus metal. Acid plus metal gives salt and hydrogen. Salt and hydrogen. For example, acid HCl plus zinc. Zinc chloride plus hydrogen. 2HCl. Zinc chloride plus hydrogen. So acid plus metal gives salt and hydrogen. So these are the reactions of acid with metals. Acid with metal. So generally when an acid reacts with base, it will always give salt and water. But acids can react with metals. So first reaction was acid with metal hydroxide. It is giving salt and water. The second reaction was acid plus metal oxide. It gives salt and water. Third reaction was acid plus metal carbonate. It gives salt, water plus carbon dioxide. The fourth reaction was acid plus metal hydrogen carbonate. Metal hydrogen carbonate. The result was salt, water plus carbon dioxide. And the last is acid plus metal. It gives salt and hydrogen. So from a general equation, you must memorize the general equation. So in a question paper, if you see a reaction of acid with metals, you can predict the products. You can predict the product. So first you identify what type of reaction it is. Acid with metal oxide, metal hydroxide, metal carbonate, metal hydrogen carbonate, or metal. Then you can tell what is the product. So that way you have to learn. You must know the general equation. So if you know the general equation, you can identify the given equation and you can write down the product. So this is the way how to learn this type of questions.